Here we go. We're going to talk about solving by factoring. And I know some people go, ooh, factoring. Put your mind at ease. It's not as bad as it looks. We're going to do it little by little, not a whole lot at once. We have been solving quadratics. What makes this a quadratic? Power of 2. That means I'm going to find 2 answers. By the way, that just means there's 2 numbers I could possibly plug into this problem and get a correct answer out of it. That's all it means. And this was also something we saw earlier where you might say, well, I could just use quadratic formula. And you could. In fact, I'm going to show you the quadratic formula. The a value is 1. The thing right next to x squared, it's right there, it's a 1. My b value for this one is -6, and I don't see a value, so I'm going to call it 0. But the thing is, I'm going to waste a lot of time here. I already know the answer to this is 0, and the other answer is 6. There's my 2 answers. It's true. Look, if you put 0 squared minus 6 times 0, well, you'd get 0 take away 0. Well, that is equal to 0. If I plug 6 in here, 6 squared is 36, minus 6 times 6, that's 36. Well, 36 take away 30, that's 0. See, I don't even need to use quadratic formula, but that's because I know what the shortcut is before I even start. But I want to convince you guys that it is much easier to do it my way. But some people go, no, I'm just going to use quadratic formula. I'm going to do negative b plus or minus square root of b squared. So -6 times -6, that's 36. Minus 4 times a times c, all over 2a. And this part right here, 4 times 1 times nothing, that's nothing. That's a big old 0. So what do I end up with? 6 plus or minus the square root of 36 over 2. And see, here's where people start getting into trouble. They start doing goofy stuff like, oh, 2 goes into 6, I'll make that. You already lost. You just lost the game. That's illegal. You can't do it. What? Yeah, because see, this right here, this guy's got to be simplified first. Well, the square root of 36 is, oh, it's 6. So I could say 6 plus or minus 6, the whole thing divided by 2. Well, what does that mean? It means, well, 6 plus 6 is 12. 12 divided by 2. That's one of my answers. That's 6. 6 take away 6 is 0. 0 divided by 2 is 0. Oh. Well, what's so bad about that? Well, here's the thing. I can take out the GCF. See, people get taught how to factor in Algebra 1, but they forget a lot of stuff. And one of the very original first skills they teach us is taking out a greatest common factor. And the greatest common factor in this problem is x. They both have an x in common. So what do? I pull it out front. And remember, if I were to distribute this back in, I would get back the original. I would totally get that statement back. So all I'm doing is I'm pulling out a x. Whenever you pull out a single letter, one of your answers is 0. That is true. It's always true. Well, what about this? Well, whenever you see anything in parentheses in mathematics, you set it equal to 0 in your head. What would I have to take, or what would I have to subtract 6 from to make 0? Well, 6. If this thing was a 6, 6 take away 6 is 0. Hey, I got the same answers doing it this way, but guess what? Let me just rocket right through that and show you. I'm trying to convince you that I'm saving you a lot of time and effort. First step is, if I see that something has a GCF in it, I should take it out. If I have a single letter, one of my answers is automatically 0. The other one, set this equal to 0 in your head. Oh, if x was 6, I'd have 6 take away 6, I'm done. Bam. There's my 2 answers. I don't want to mess around with a quadratic formula when I know there's a faster way. Now, I could do this one using quadratic formula too. I could. It's not wrong. It's long. I'm trying to keep the same pattern here. What's the common factor? What is the GCF? And in this case, the greatest common factor is x to the first. So I say x, and then I have factored this quadratic. Now, these are unique quadratics because they're not trinomials. They're just two pieces of the puzzle. But if you look back at the video that we just got done doing, you'll see that I did these a quick way. I don't have to use quadratic formula. What's the answer here? Anytime you pull out a single letter, 0 is one of your answers. Set this piece equal to 0 in your brain. -2 plus 2 would be 0. Oh, so my other answer is -2. I am done. I totally am. It's fast. Factoring is not the devil. Let's try this one. Wait, there's a 4. Yeah, that's okay. I think 4 also goes into 20. And they both have an x. Well, that's more. There's more stuff this time. That's okay. You're looking for the greatest common factor. The greatest thing they have in common. Well, 4 goes into itself. 4 goes into 20. Okay, I'm taking that out. They both have a variable of x. I'm taking that out. Build it backwards. What would I have to multiply? Oh, x. Oh, 4x squared. Minus, what would I have to put here to make that a true statement? I think it's a 5. That is called factoring, ladies and gentlemen. That is factoring. You can take out a greatest common factor. In this case, it was 4x. And then you might say, well, is this still 0 because there's a 4 in front of it? Yeah, it is. It's still 0. Whenever you take out a single letter, you will find 0 is a true statement. But what about 4 times 0? It's still 0. Whoa. Yeah, it's true. So right here, what's this answer going to be? It's going to be 5. Because 5, take away 5, would give me a 0. Here's my 2 answers. Oh yeah, let's remember, every quadratic equation has 2 answers. So in this one, the 2 answers are 0 and 5. Let's look at another one. Oh man, this time it doesn't say equals 0. Okay, that's fine. Remember, to solve, and this is in all the videos, to solve any quadratic equation, we set it equal to 0. There's only one time we don't, and that's if we're going to do the root method. That's the only time we don't do that. Well, what do I do? Listen to the Red Hot Chili Peppers. Take it away, take it away, take it away now. Bam, that guy's not there anymore. What's over there? There's nothing. And then let's call it 0. Over here I got 3x squared minus 30x. What's it equal? 0. Do you see the GCF? Well, it looks like they both have letters, so x is part of it. Hey, 3 goes into both. Oh, I'm going to pull out a 3x. And then I'm going to build it back. Right? Build it back. What would I need in here? I'd need another x, and I'd need a minus 10. And by this time, I'm hoping you are not afraid to factor something like this. And you go, oh, that's 0. That's 10. Those are my two answers to any quadratic equation. See, it's not that bad. So let's go down, and you go, wait, now you're pulling one on me. That's different. Yeah, it is. There's no GCF. Doesn't have to be. There's no guarantee that there's going to be a GCF, ever. But the first rule in factoring anything is, if there's a GCF, you take it out. if there is a greatest common factor, you factor it out, take it out. Well, what if there isn't one? Well, then you don't have to do it. Well, what do I do next? I'm going to do quadratic formula. Okay, you do that, but I'll be done before you're done. See, if I want to get x squared out of this, I know that this is 2 binomial. I'm going to go x times x. That's what I'm going to do. That's how I get the x squared. Let me get that out of the way, though. I don't... Whoop, come on. Ah! Stupid thing. There we go. All right. Well, what about this 14? Not just a 14, it's a negative 14. Well, I can tell you this much. The only way you're going to get a negative 14 is if one of these is a positive and this is a negative. That's the only way it's going to work. Well, what about it? What do I do? Well, it's either 1 times 14 or it's 2 times 7. Now look at this. Think about it. 2 times 7 is 14, and 7 take away 2 is 5. You might not have factored in a while, but I'm going to give you a little hint. That's the answer for factoring it, but that's not the answer to my equation. Remember, my equation is going to have 2 answers. Those 2 answers are going to be numerical. So I'm setting this equal to 0. I don't have a little letter out front. I don't have that going for me this time. But whenever you see parentheses in mathematics, you set it equal to 0 in your mind. So guess what? The answer here is negative 7. The answer here is 2. You are done. Now, factoring is a trick that we use to break things down into binomial components if we can. How do you know you're going to break it down into binomial components? You play around with it. You see if you can find a pattern. And let's look at another one. Okay, here we go. This one's easy peasy because I only have one possible way to do this one. How do you know? Because there's only one way to write 3. 1 times 3. That is the only option I have. So let's try to break it down. Well, why didn't you try to take out a GCF? Because there isn't one. Take a look at it. I got X. I got X. I got no X. I got a 2. I got a 3. Well, they don't even have anything in common. What about me? I'm a 1. Not going to help. Not everything has a GCF. It's okay. But I know how to get x squared. It's x times x. It is. I want it to end with a negative 3. I want it to end with a negative 3. So one of these has to be a positive. One of them has to be a negative. Well, if I put the 3 here and the 1 here, is that the same thing as if I put the 1 and then the 3? Well, let's see. My dog's barking. He's saying no because he's really good at factoring. That's x squared. That's minus 3x. That's 1x. That's minus 3. Oh, so I get an x squared. I get a minus 3x. I get a plus 1x, and I get a minus 3. Yeah, there's that. There's that. And this plus this is wrong. Oh, so here's the thing. The beauty about factoring is every problem that does factor, and we know some of them don't, but every problem that does factor will only factor one unique way. It is true. It's not a lie. We're going to set this equal to 0, and then we're going to do the opposite game. What would I have to plug in for x to make that whole chunk of the puzzle equal 0? Negative 3. What would I have to plug in here? Uno. Es la verdad. There it is. There's my answer. I have 2 of them because it's quadratic. And that is why we teach you in Algebra 1 how to factor stuff. Because these are the solutions to these equations. We factor first, then we set them equal to 0, then we finish the problem off. Let's play again. Oh, 30. 30 is a big number. It is. 30 could be 1 times 30. It could. It could be 2 times 15. It could be 3 times 10. It could be 5 times 6. There's all kinds of junk that goes into 30. Hey, every problem we did so far had a minus here. What if it's a plus? Oh, that's even easier. Let's break it down. I know x times x is going to give me x squared. I know that. I want it to be a positive 30, so I'm going to clue you in on something. If you want it to be a positive number at the back, whatever this sign is has to go in both parentheses. Let me say that again. If you want this to turn out to be a positive 30, then you look at the first sign, and whatever's there goes in both. So I'm going to put pluses in both. Now take a look. I need to come up with 17. Wait, I'm stopping right there. 2 plus 15 is 17. And 2 times 15 is 30. And I have just unlocked this baby. Now, if you need to, the things I'm trying to say to you in this video, you can rewind them. You can watch it. You can write it down so you have it in your notes, but then rewatch it, and then maybe it might click the second time through, the third time through. And if not, I'm in the Zoom room. That's a -2. What's the answer here? -15. I have 2 answers. I am so bold as to say that thing is solved. Factoring a quadratic to solve is not a bad thing. A lot of people, oh, I'm afraid of factoring. I'm not good at factoring. No, let it be easy. Look at that. I already see it and I go 8. Could be 1 times 8 or it could be 2 times 4. But one of those combinations is going to give me a 2 in the middle. Let me clue you in. X and X. It needs to be a -8. Wait, we already knew this rule. If it's going to be a -8, one of these has to be positive, one of these has to be negative. So here's the only thing you have to be careful of. If I put the 4 here and the 2 here, I'll still get x squared. I'll still get -8, but I will not, whoa, that was weird. But I will not get a -2. I would get a positive 2x. So the only thing you have to watch out for sometimes is, did you put the signs in the right place? No, I did not. I have to switch those. I should have made this the negative and this the positive. Then it would have worked out and I would have had it factored correctly. And then it's easy peasy. What's the opposite? What's the opposite? There it is. We're in business. All right, when you guys do get to the practice problems, you're going to see I'm just giving you practice like this. And then you go, yeah, but what about this? I'm also giving you practice like this. I know, you're like, thank you. But I'm also trying to do this little by little. We're not going to do everything in one day. We're not even getting everything done in this one unit. We still have many units to go. But I'm telling you now, what makes this one look different than this guy or this guy or whatever? What makes them look different is I put a number out in front here. But guess what? See that number out in front? It's a GCF. It is. 5 goes into itself, 5 goes into itself, 5 goes into 30. All right. A GCF does not always have to be a letter. Doesn't have to be a number. Sometimes a GCF could be a number, a variable, or both. Let that sink in. It could be a number, it could be a letter, it could be both. This one, it's not both, because I got an X, I ain't got no X. All right. Poor grammar choice, ain't got no, but I can take a 5 out. Work it backwards. This thing is a trinomial, so let's make it back. 5 times x squared is 5x squared, plus 5 times x is 5x minus 6. And then we're going to take this and we're going to bustify. We're going to go, what? Well, what happens to the 5? Leave it out front. X times x is x squared. It needs to have a minus 6. We're not worrying about 30 now. We don't care about 30. We just want a 6 back. Well, then, I'm going to do 1 times 6. 1 times 6 is 6. Don't jump the gun. What do you need in the middle? You need 1x. I think 1 times 6 is 6. I do. But I think 2 times 3 is also 6. And I think that combination will yield what we want. So let's get rid of some of this junk. I just stuck it in there. I can always erase. That's why Mick Jagger invented the eraser. It's true. Double check me. I think that is x squared. That's a minus 6. There's 3 x's. Take away 2 x's. Party. There it is. Now, what about... Wait, I'm supposed to call that 0. No, you are not. Do you see a single letter there? No. You see a single number there. When you take a single letter out front, that means 0 is one of your answers. But when you take a number out front, that just means you reduced all the numbers and made your life easier. That's all it means. So let's finish off. That answer is negative 3. That answer is positive 2. That's what you just found. And why? Because there's only 2 answers to this. Quadratics always have 2 answers. Telling you, it's true. So, by the way, this is the last thing we're going to talk about for this unit. We have more to do, but it's not going to happen today. So let's take a look at this one. Do you guys see the GCF in there? There is. This one has a greatest common factor. It's a 2. 2 goes into everything there. So let's build it backwards. 2 times x squared, that's 2x squared. Minus 2 times 2x, that's 4x. Minus, what is that, 24? Yeah, that's 24. Hey, let's bustify. Let's make this thing break up. I need an x times an x. I need a negative 24, so I need these to be opposites. And 24 is a jerk because it's a lot of stuff. 1 times 24, 2 times 12, 3 times 8. But here's the guy I want, 4 times 6. Why do I want 4 times 6? Because I know that if I put a 4 here and a 6 here, check it out, that would be 4 x's. That would be minus 6 of them. 4 take away 6, negative 2x. I'm going to erase that, but you might want to pause it and just kind of vibe on that for a second. But I'm going to get rid of this so it's not in my way. There's a 2 out front. It equals 0. That's not a letter, that's a number, so leave it alone. Don't mess with it. Negative 4 is one of my answers. Positive 6 is the other answer. Those are my answers. I got one more for you to play with. Let's play with this one. You go, what? Doesn't 6 go in all that junk? I think so. Well, what if it doesn't? Well, there's all kinds of what ifs in life. There you go. Let's break it up. X and X. Ooh, it's got to be a positive 4. So I already told you this trick. If you know it's got to be a positive, whatever's in the front goes in both. Bam, kabam. And you might be going, well, 4 times 1, that's going to give me 5 in the middle. Yeah, but don't forget there's 2 times 2. Oh, yeah. I went there. Now, you get an answer here that's negative 2. You get another answer here that's also negative 2. I'm not kidding. That can happen, but there's supposed to be 2 answers. There are 2 answers. They just happen to be the same answer. Okay? In mathematics, we call this thing a double. I'm not kidding. We call it a double. Doubles happen twice, right? So there you go. You have the. Do you have to write the answer twice? No. But on my answer key, I did write the word double so that you don't panic and think you did something wrong. No, it can happen twice. So let's see here. What? Now you're really... What's wrong with this one, guys? If I want to solve a quadratic, oh, I'll do this. Root, root. No, you won't. That's not right. This is not one of those type of problems. Well, I need it set equal to what? What do I need to set this equal to then? If I can't root it, set it equal to 0. I'm going to move this 15 to the other side. I'm going to say, get out of here. Well, if I do that, let's put it in the right order. Let's put it in the right order. And it equals nada. And then I go, wait, that's got a GCF in it. 3 goes into all that stuff. It surely do. And this one you can't get wrong. X times x gives you x squared. It's a minus 5, so it's got to be a positive times a negative. And 5, you can only write it one way, 1 times 5. You just got to make sure you put the stuff in the right spots to get it correct. Double check me. Take a look at that. Did I do that right? I think I did. But I still don't know why sometimes we say one of our answers is 0. Well, you only say one of your answers is 0 if you pull a letter out. That's not a letter, that's a number. Well, what do you do if... just let's get so far. We can't get everything done all in one day. So this is as far as we're going today. And then we'll talk about it as we progress through the next unit. My answer here is -1. My answer here is 5. There's my 2 answers. And I say, dang, I was supposed to find 2 answers anyway, because that's what we do when we solve quadratics. We find 2 answers to every question. Now, somebody always says, couldn't I use quadratic formula for this? Yeah, you could. But you know what? The first step to make it easy would still be set it equal to 0. Oh, I did that right here. The second step to make it easy would be take out the GCF. Oh, I already did that. Well, then you're already at the spot where it's not that hard to do. And if you want to use quadratic formula, you can. But I always warn people, factoring is faster. It is. And you make less mistakes. So here's the takeaway from this lesson. Keep this in mind. There are many things that can happen. What if there's no GCF and there's a number out front still? What if it looks like this? 2x squared minus 5x plus 9 equals 0. What if I can't take out a GCF? Well, guess what? That's not on this test. Oh, so if it's not on the test, don't worry about it yet. Okay, so that is not an issue. What if it has a power bigger than x squared? What if it says something like x third minus 6x squared plus x? What if it says that? We haven't done that yet. You're correct. We have not done that yet, and it will not be on this first test. Oh, what if it doesn't factor? What if? We will cover the other situations little by little. Okay? And you already know the answer to what if it doesn't factor. If it does not factor, then it's either a cheerlead problem where you root, or you have no choice, you have to use quadratic formula. That's what you do if things don't factor. But there's a lot of what ifs. I get it. There's a ton of what ifs. What if they're not on the test this unit? Well, then let's worry about them when we need to worry about them. Because I'm not going to put stuff on the test that we have not covered yet. And that is the conclusion of this lesson. Now, where's the practice? All the way at the top. Here we go. All of these examples. Oh my gosh, wonderful. All of this stuff. Oh my gosh. But, here we go. Solving quadratics by factoring. Solve each by factoring. So here's your assignment, and this is, I don't want to say it's the last one in the unit. I think it is though, but I'm not. Anyway, solve each by factoring. There's 12 questions, but that's only because I could only fit 12 on this screen at a time. So take a picture of it, and then I'm going to show you. There's 2 more at the bottom. Then I'm going to show you there's 6 more on this page. So pause it, take a picture of it. And what you should notice is I did not put anything here to practice that I did not already show you an example that is similar. Then here's the answer key. This all does fit on one screen. So take a picture of the answer key so you can check it when you go through and notice, hey, that happened twice, that's a double. That happened twice, that's a double. So guys, as always, if you get stuck, please ask questions. I will answer whatever you need to. And don't be afraid to be wrong, because that's how you learn sometimes. Anyway, I hope you enjoyed this walk down the factoring technique method lane. Oh God, that sounds stupid. Okay, I'm going to just say bye.